All right, so the third method to solve systems of equations, we talked about solving by graphing, solving by substitution. The third method that I want to show you is called solving by elimination. And what elimination means, the name kind of tells you what it means. It literally means that we're going to pick one of the variables, either x or y, and eliminate it. Okay, so how will we do that? Well, let's look at number one first of all. We want to eliminate one of the variables. It doesn't matter which one, but I'm going to pick y in this case. And the reason I'm going to pick y is whenever I see a 1y or a 1x, in this case the 1 is in front of the y, it's easier to eliminate the variable that has 1. How will we eliminate? We basically need the numbers in front of the y to be the same. Either the same or one of them can be positive, one can be negative. So that means I have a minus 4 right there. That means I want this bottom equation to have some version of 4 in front of y. I'm going to make it positive 4. How can I make a 1 into a 4? I can multiply by 4. So the top equation is going to stay the exact same. Just going to recopy that. Okay, the bottom equation, if we distribute the 4, and it has to be multiplied by everything, that's important. 4 times 4x is 16x. 4 times 1y is 4y. And 4 times negative 13 is negative 52. Okay, now we can eliminate. So the question is, how could you eliminate the minus 4y, the plus 4? You could either add or you could subtract. If you try to subtract, if you did negative 4 minus 4, you'd have negative 8y. That would not eliminate the y's. The only way we can eliminate them is by adding them. And if you add the y's, in order to be consistent, keep these equal to each other, you have to go down the line adding the same thing each time. So 3x plus 16x is 19x. Negative 4y plus positive 4y, those eliminate each other. That's why it's called elimination. We eliminated the y's, which is exactly what we wanted to do. And then finally, negative 5 plus negative 52 is negative 57. Now we can solve for x by dividing both sides by 19. We would get x equals negative 3. And then if we want to solve for y, we can do what we did on the other problems, which is substitute in our x value. Okay, so it doesn't matter which one. Let's just do the first one. So 3 times x is 3 times negative 3. And we're trying to solve this for y. So 3 times negative 3 is negative 9. We will add 9 to both sides. Negative 5 plus 9 gives us positive 4. And negative 4y equals positive 4. So if we divide by negative 4, we would get y equals negative 1. So our final answer should be x equals negative 3, y equals negative 1. All right, try and pause the video now and see if you can do number 2 on your own. It's slightly harder, but same basic idea. When you're ready, hit play. So hopefully you gave that a try. So number 2, we decide which variable we want to eliminate. It does not matter which one. In this case, I'm going to choose to eliminate the y. Again, though, it doesn't matter. So the idea is we need these numbers in front. We need them to be the same, and right now they're not. So the easiest way to think about this is suppose you were adding a fraction that had a 4 on the bottom of one fraction and a 3 on the bottom of the other. What would you need to do before you can add them? And the answer is you need a common denominator, which in this case would be 12. So you would basically multiply this one by 3, and you'd multiply the 3 by 4. So we'll do the exact same thing. What you're basically doing is you're finding what's called the least common multiple, or the least common denominator of those two numbers, of 4 and 3. Okay, and so let's do that. So how can we change the 4 into the common denominator is 12, so how can we change this top one into 12? We get rid of that. We can multiply by 3. So when we do that, we'd have negative 15x plus 12y, and 3 times 14 is 42. And then on the bottom, we need this to be a 12, so we're going to have to multiply by 4 this time, because 4 times 3 is 12. So 4 times 3x is 12x, 4 times negative 3y is negative 12y, 4 times negative 9 is negative 36. Okay, once again, the question is, do we eliminate by adding or subtracting? If we subtracted, if we did 12 minus negative 12, that's the same as 12 plus 12. That would be 24y, and that would not eliminate the y's. So basically, if 12 and negative 12, since those are opposites, we eliminate by adding. If you suppose you had both of these were positive 12y, in order to eliminate, in that case, you'd have to subtract. But in this case, we're adding because one is positive 12, one is minus 12, and you eliminate opposites by adding them. Okay, to keep this consistent, we have to add everywhere. So negative 15x plus 12x is negative 3x. Those are eliminated because 12 plus negative 12 is 0. And then 42 plus negative 36 is positive 6. So we can divide both sides by negative 3. We would get x equals negative 2. Let's solve for y by plugging in the negative 2. Let's just do the bottom one. So 3 times negative 2 minus 3y equals negative 9. 3 times negative 2 is negative 6. And then we will add 6 to both sides. And we'll get negative 3y equals negative 9 plus 6 is negative 3. So if we divide by negative 3, we would get y equals positive 1. So our final answer is negative 2 comma positive 1. So that's how you solve systems by elimination, and that's probably the most commonly used method. It tends to be one of the easier ones once you get some practice with it. So practice this a little bit, and hopefully it makes sense.